Hi everyone, my name is Dr. Paul Kerstetter, and today I want to talk about doubling a voltage using a switched capacitor circuit. There's something oddly satisfying about being able to double a voltage with such a simple circuit. But as always, when one parameter increases, another has to decrease. I'll show you exactly which parameter that is. Let's get started. This is the presentation, Voltage Doubler Circuits, a Switched Capacitor Circuit Discussion. The slide shows a circuit that doubles the input voltage Vin. It uses only switches, a capacitor, and a supply voltage. In effect, the circuit alternates between two topologies to achieve the voltage doubling. The circuit from the previous slide is broken down into its two operating states in this slide. Intuitively, if you place 1 volt across two capacitors in parallel and then reconfigure them in series, you would expect the voltage to double. This voltage doubling is illustrated in the slide. The underlying mechanism at work is the conservation of energy. The total energy of the two capacitors combined must remain the same, even though the circuit configuration changes from parallel to series. Remember that for capacitors in parallel, the total capacitance is the sum of the individual capacitance. If we let VDD1 equal VDD2 equal 1 volts, and C1 equals C2 equal 1 farad, then the total energy on the parallel combination of capacitors is 1 joule. Remember that for capacitors in series, the total capacitance follows the formula shown on the slide and is 0.5 farads for the combination. Since we know the energy of the parallel combination is 1 joule, then we know that it is the same for the series combination. Solving for Vs in the equation on the slide yields 2 volts. In effect, we went from 2 farads of capacitance to 0.5 farads, and the voltage doubled in the process. Energy was conserved in the process and didn't change. In the next part of the presentation, I'll show you how to simulate the voltage doubling of the circuit shown in the slide using LT-Spice. So this is the LT-Spice demonstration. As you can see, I have the two topologies, or the two states of the circuit, one when they're in parallel and one when the capacitors are in series. This is a simple simulation. It's just 1 volt across two parallel capacitors, and when we probe it, we'll get 1 volt. This is a little bit more complex. It has the two capacitors, and it also has initial conditions of it on it. The initial conditions are voltage, and the initial conditions are 1 volt across each capacitor. So what's happening in this case is we're going from phase 1 to phase 2 when the switches switch from parallel configuration to series configuration. And we can run the simulation, clicking on that arrow. And when we probe it, as you can see, we get 1 volt in the parallel configuration and 2 volts when it's in series configuration. Now to set the initial condition on the capacitor, all you do is right click and you put in the capacitance, comma, IC equals 1, and the 1 is 1 volt. And so that's how you get the initial conditions on the capacitor. Okay, there we go. So this is the circuit with switches, and it basically, as you already know, it changes from parallel configuration to series configuration for the capacitors. These switches are available in the components selection menu, and there you just click on that, and then you'll get a switch to place. But it won't work until you put in this model statement, and the way you put that model statement in is you go edit spice directive and you type that model SW close brackets, and that puts in the default model for the switch, and that'll put it right there. The pulse is set up like this, and that can be gotten from the components menu. And it starts off at -1 and it goes to 1, a delay of 0, 0.1 rise time, 0.1 fall time, 1 second on, and then a period of 2. So it's, it goes from -1 to 1 for 1 second and back down to -1 for 1 second. And so that's that pulse. This one is inverted, and so it starts off at 1 and goes to -1. So that's the opposite of this pulse. And that controls the switches. Those two voltages control the switches. And here's your 1 volt. And let's run the simulation. Here's the 1 volt supply. As you can see, it's 1 volt. And then on the output of the series connected capacitors, you can see it jumps from 1 volt to 2 volts. There you go. It goes from 1 volts to 2 volts. Okay, that's the end of the presentation. I hope you enjoyed this video. If you enjoyed this video, please like it and subscribe to the channel. Stay safe, and I'll see you in the next video.